So here we have a word problem. And I want to make sure that we don't freak out over word problems, and we take it step by step. We've worked many like this before. We're just incorporating substitution in order to solve the system of equations. So let's make sure we have a clear understanding what the problem is asking or stating as well. And as we read, it says, together, teammates Pedro and Ricky got 2,686 base hits last season. So together they got that amount of hits. We know that Pedro had 274 more hits than Ricky. How many hits did each player have? We're going to have to write an equation. In order to write an equation, though, we know that Pedro and Ricky have to be involved in the equation. So I need to let Pedro represent a variable as well, as Ricky, allow Ricky to represent a variable. So it does not matter which variable you choose, but I've chosen Pedro to represent X and Ricky to represent Y. Now, in order to write the first equation, let's read the first sentence again and see if we can create an equation from that sentence. It says together, and I know when I put things together, I combine it with addition. Together, these teammates, Pedro, which is X, and Ricky, which is Y, together to get 2,686 base hits. So Pedro is X and Ricky is Y, and when you combine them, together they have 2,686 base hits. This is my first equation in my system. Now let's go on to read the second sentence. Pedro had 274 more hits than Ricky. As we think, who are we talking about in this sentence? We are talking about Pedro. Well, what does Pedro represent? Pedro represents X. So Pedro, which is X, had a total of, which would represent equals, a total of 274 more hits. When we talk about more, it's addition, than Ricky did. Well, because we don't know the amount of hits that Ricky had, and we know that Ricky represents Y, we write the equation that Pedro, X, equals Y, Ricky, plus 274. That is stating that he has 274 more hits than Ricky. Now, since we have written our system of linear equations, we will use substitution to solve. Once again, I state that it's important to make sure our main goal is to isolate one of the variables in one equation to be able to substitute it in. I want to be able to write an equation with the same variable instead of having two equations with two different variables. So I have that X equals Y plus 274. So I know that I can plug in to this equation my second equation tells me that this X equals Y plus 274. So I'm plugging in Y plus 274. Continue to write the rest of my equation. Now, using the four rules, you can look back at the last two videos if you need those rules. Although we do have parentheses, there's not a number outside the parentheses, therefore we do not have anything to distribute. So you can actually get rid of these parentheses at this point. So when I do that, I just have Y plus 274 plus Y equals 2,686. Now my second step in solving an equation is to combine like terms. That means on one side of the equal sign, you combine any like terms. I have two y's, so 1y plus 1y equals 2y. Combine those two y's together. Plus 274 equals 2,686. My third rule states that my variables are on my left. I look and find my variable in this equation, which is y. My y is on the left side of my equal sign. Now I'll go into my fourth rule, which states that my constants go to the right. I look on the left side and I see that 274, which is a constant, is still on the left side. In order to move this constant to the right, you do the inverse of what they are doing. They're adding 274, so I will subtract 274. When I subtract, I must do what I do to one side, I must do to the other side of the equal sign. Subtract 274. Positive 274 minus 274 cancels out. Now I bring down what I have in my equation, which is my 2y, and I will subtract 274 from 2,686. Remember, you may use a calculator, but this is also simple math. 6 minus 4 is 2, 8 minus 7 is 1, 6 minus 2 is 4, and 2 minus 0, because there is nothing there, is 2. And then my last step would be to divide, because I have to get y by itself. Therefore, I do the inverse of what they are doing. Because they are multiplying by 2, I will divide by 2. And what I do to one side of the equal sign, I must do to the other side of the equal sign. 2 divided by 2 cancels out, leaving me with just y. Also, you may use a calculator, but 2 divided into 2,412 is 1,206, if I am correct. Okay. So once again, all this work and all I have solved for is y. Okay, but from here it's easy. I use this y, this solution for y, to plug into either one of the equations to solve for x. So I'm now trying to solve for the second variable. So plugging in back to this equation, I'm choosing the easiest equation, does not matter which one. But I know that y equals 1,206. So I'm going to plug in y into this equation. This leaves me with x equals 1,206 plus 274. And when you add these together, you get 1,480. So I have x to equal 1,480. Now I do want us to check. So our last step would be to check. All we do is plug in y, x and y into the equation and make sure that each side equals one another. So once again, I leave out the step. I want to write this as an ordered pair with my x being first and then my y. So I have the ordered pair 1,480 representing x and 1,206 being the solution to y. Here I go, plug in 1,480 for x, 106. I'm going to add it together. 4 plus 2 is 6. 1 plus 1 is 2. This does equal 2,686 equals this right side, 2,686. This does hold true for the first equation. However, x and y has to hold true for both equations. X being 1,480 equals 1,206. Bring down what I have on the left side, and I will add these two together. 6 plus 4 is 10. Carry a 1. 0 plus 7. 7 plus 1 is 8. 2 plus 2 is 4. And then a 1 plus nothing over here would just be 1. And 1,480 does hold true. Therefore, these solutions for x and y are the solutions to the system of linear equations.